Hello colleagues, let me introduce myself. I'm Igor Bardowski, Sales and Support Engineer of Woodwork for Inventor team, and today I'm honored to present workflows and features of Woodwork for Inventor version 11. We spent an entire year on developing new features to make Woodwork software great for the users. So what this presentation is for? We wanted to make it interesting for both for existing and as well as for new potential customers. So therefore, it will be not a comparison between 10th and 11th version, but this will be like a workflow and feature presentation for you. So first of all, let me speak about what is a Woodwork for Inventor in general. What is that kind of software? Most of you perfectly know Autodesk Inventor software, which is great for making something. It's not only limited by furniture, so you can do something with metal, frames, and whatever else on the mechanical side. But this software is not primarily oriented for the furniture making, for the woodworkers. So here we can make furniture of any complexity and any shape. We can embed some parameters and logic, but on the other hand, Autodesk Inventor, like a standalone software, is missing some of the features. So we try to fix that by Woodwork for Inventor, which makes possible to assign woodworking attributes such as materials, grain direction, edge banding, apply hardware, make holes, and of course to do all the tasks in the background, all the calculations, to prepare a set of data for manufacturing. So those two packages are working in a tight connection, so it's not possible to just download Woodwork for Inventor standalone. You must have Inventor as well. And now let me familiarize you with the workflow and as well with the model we will use for our demo. Everything starts with the skeleton. So what do we mean by that? It's a simplified model of your future furniture, which will be used to check your initial design idea, if everything works as expected. Then, if you see that your skeleton is working correctly, you can make actual assembly and tie the materials to the components. Once it's done, then the hardware set can be applied. Some of the components can be designed in advance. They can contain the model, the materials and the hardware, and this can be like furniture blocks. For instance, the drawers, doors, and so on. That can be done in advance before you start any design. What we can do on the next step, we can just say that we made all the design things, and since this moment when we have our final model completed, this model can be used like a standalone source of the data for the next steps, which is automated generation of the bill of materials, drawings, nesting files, and of course CNC programs with the simulation capabilities. Now let me guide you through all those steps in details, and we will see what you have in each of those steps. Everything starts with the skeleton design, and as I mentioned already, this is like a simplified model of your future refined unit. So what do we mean by that? Everything starts from general shape. In this case it will be like boxy looking furniture, as you noticed, and when we do it, first we define some parameters to control the size. Since this will be just a simple box, we can define the width, depth, and height of this box as a parameters, and you can see that we do this by typing the name and assigning the value. Okay, like so. You can also use some relations between the parameters, like in this case the left partition and right partition offsets will be the same. You can also use equations, formulas, and so on. You can even mix the parameter between different files. So when you have this list of parameters, this can be used in your design. So in this case, I want to split the furniture unit in multiple blocks, and then those blocks will be defined. So what I'm doing here, I'm making some work planes. And when I'm doing so, I'm using the parameters from the list we defined in a few steps ago. So this is looking like so. As you can see, there's nothing really complicated. Now we are using the tool of a Woodwork for Inventor, which makes possible to apply panels on the surfaces of this initial skeleton, which of course can be not only a box but something more advanced, but I choose this model to make my explanation clear. Okay, what we can do as well, we can set the panels to be in the intersection between the work plane and the solid body. So in this case, those vertical separators will be done in that way. And the same can be done for the shelves. So as you can see, there is like a cone indicators which defines in what direction the panel will go. So when you define the work plane position, you can say that that will be a niche size, or that will be limiting factor for the shelf or another panel. As you can see, when I'm doing the design, I'm using a parameters a lot. So once all the panels are on the place, we can use a great tool which is called trim. And as the name tells, you can use some component as a boundary. And as you can see, I used the door as a boundary component. And this door cut all the panels which intersects with it. Now we can repeat this procedure with the remaining panels. To save your time, I speed up this process a little bit. So as you can see, what we are doing, we actually trimming, splitting the panels, and using the trim operation to make a right join between them. And here you can use any design intent you want. So the top panel can lie on the sides or vice versa. And after a few minutes, our model have the division between the panels, so we divided them in the right way. So what can be done on the next step? It looks a little bit unusual. Instead of defining the shape of the component, we just define another box. This box will be used to place the eyeboxes of the drawer in that place. So what I'm doing, I can make the drawers in advance and then place them in the right position by just simply indicating where they should be resided. So that will be like just a placeholder, if we can name it like so, for the next operation. And now we're just finalizing the design, adding a few more fine steps here and there. Like for instance, we can draw the shelf. There is nothing really special here, so that's why I speed up it a little bit again. So it's like a regular design of the sketch. That's it. That's the sketch of the shelf. We can define the size, the tilt angle, and whatever else we want to do. And then just make a new solid, which will be then later translated into the new part and then combined in a new assembly. So we can define the size of the panel by just indicating the limiting factor, which in this case will be another side of the block. And then later this sketch can be set visible one more time to use for the next operation. So you can have geometry for multiple solid bodies in one single sketch, if you like. However, I prefer to make sketches simple, so in my opinion, it's better to have two less complicated sketches than one more advanced. So as you can see, in a matter of minutes, we get something which starts to remind the furniture. Now I made a work plane in the middle, and then I use a split tool to define the split of the front. In this case, I'm not using the origin center plane for a reason that this split, those proportions can be different. Yeah, and later we will see what I mean by that. So I can make one of the doors bigger than the others if this unit will be non-symmetrical. So each of the doors will be unique. So what I'm doing now, I'm splitting the front into the door panels. Those will be later used to place the eye boxes, the tail models of the doors. And what we do in the next step, we define some descriptive names which will allow you to understand what is what here. So as you notice, despite the fact that I speed up this process a little bit here and there, this doesn't take a lot of time. So you can expect, like, making your initial design idea in 10 or 15 minutes or something similar. Of course, it depends. Maybe you have like very complicated model. Then there's another approaches that can be used. You can see them in our other videos in social media channels. Main idea then will be to split the general block in multiple pieces and then detail each of those pieces separately. So now let's talk a bit about the materials, because they matters a lot. Speaking about materials, we have such main material types like profiles, solid wood, and different kind of boards, which includes a laminated board, raw board, and the desktops. And as you notice, they all have their own measure units, like profiles measured along the length, solid wood parts measured by volume, and the boards are measured by their occupied area in the model. So some of those models may be covered with the cover materials, like for instance the raw board can contain a laminate on the top and the bottom as well as on the sides. Laminated board can be also covered by the edge banding, and we have a separate desktop type of the boards just to have a separate group. Now let's speak about more advanced material types, and here we see a multi-layer board. There's like a new feature of 11th version, the multi-layer board constructor. So what we can do, we can define a multi-layer board when we actually need it. So on a model, we have a model in the final thickness, and now I'm using a material editor to define, not material editor, but material assignment window to define the multi-layer sandwich, like a structure of a multiple boards glued together to make the thickness in the way you like. So when I do so, I define what those layers would be. So it starts from the veneer on the top, then I have MDF panels or HDF panels, whatever I need. And then I will use another veneer or compensation film on the back side. And as you can see, it automatically calculates the thickness of all those layers based on the total thickness. So here you can use multiple flexible layers if you want, and then those will be evenly spreaded, which is like not the case in the 10th version. So I think you will like it if you're working with those multi-layer boards. Let's see what do we have in a BOM. As you saw, we had a simple part, then we set what those layers would be. And what we will see in the BOM, it will be actually exploited view of this multi-layer board. So we'll have each of those layers in our BOM separately. But what in case if you're using something more complicated than that? What if our layers are not the same in shape? So it can be also handled by Woodwork. And in this case, we are dealing with the composite structures then. So what this composite structure means, it actually depends on what you are designing. So maybe you want to get like a light but robust enough panel. And how you can achieve that? You can use like a panel frame, then you can cover it by the profiles. And what can be inside? That can be some light honeycomb structure material, which is not very rigid. But if you try to bend it, it will withstand your load because it has some panel underneath and the frame around, which can be used to mount some furniture, hardware, and so on. So we can also define those composite structure models in advance and then use them in our design. So what is inside and how we measure it depends on the structure. So you actually can design wherever you want. The cover materials, what is that? We want to make our furniture look nice. So therefore all the naked edges must be covered with something. And we can do this using edge banding, paint or lacquer or varnish, so it depends. So everything that can be applied like a liquid cover material. And of course we can use veneers or laminates on the top. What we have in the BOM, if you use vanilla Inventor before, you know that each panel in Inventor, each part in Inventor is like one single item. But if you have Woodwork for Inventor, then there is something more than that. So we can exploit the structure of each of the panel and treat it like a small assembly, which can be made of a laminated material on the top, some core material, another laminate on the back, on the bottom side, and everything can be covered by the edge banding. Moreover, each of those layers can be different in size depending on the different grain directions, on the oversizes, and all the technological things we may apply. For instance, the edge banding direction. Because we can make the edge banding going inside of the model, making the workpiece smaller, or vice versa. So now let's see how this material assignment stage looks like in Woodwork. We have our model converted into the assembly. So all those solids from the multi-solid part was converted into the assembly. And what we do now, we just set the main material for all the panels. And then I can apply the veneer or edge banding, it depends what I will choose. Okay, so I will use the veneer in this case for the edges, like so. As you can see, I can select one single edge and goes around. So in the same way, we repeated this grain direction assignment for all the panels. Okay, so now we can change the grain direction, and this can be done on a multiple components in one step. So I'm just choosing the components I want to align, and then I'm choosing the reference edge, and that's basically it. So you can see that the grain direction changes. So you can do this on multiple selected components in one step. Okay, so now let's flip it over and do some adjustments of the grain on the back side in a similar manner. So you can see that I can collect the components, then say I want to align the grain direction by edge, and just click on the reference edge. That's basically it. Of course, you can set custom angles if you like, and this of course will change the size of the workpiece. Okay, now I can use a highlight tool to see what is the material assignment, what is the cover material set to the model. As you can see, those arrows indicate in what direction does it goes. And also we can define some oversize for the panels if we need so. So I can select a single panel, and then you can see left, right, front, and back indicator for this panel depending on the grain direction, and we have it rotated. So now we can set the oversize from left, right, front, back, and as well that we can define the sizing oversize for a CNC machine. So now you can see that we have all those oversizes set. Moreover, the oversize can be attached to the material. For instance, if you're working with the veneers a lot, in most cases those veneered panels always should be a little bit bigger. The workpieces for those veneered panels should be a little bit bigger. So you can assign a default oversize for the veneer, and there will be no need to set it manually each time. It will be assigned automatically on the moment when you set the veneer on the panel. Okay. So now let's speak a bit about the hardware, because it's a very interesting topic here. So Woodwork installation includes some hardware items. So let's take a look how they are made. They're made like axle-driven components. If you worked with Inventor before, you're probably familiar with the iParts and iAssemblies. So we use this functionality. Beside that, we have some automated placement instruction embedded in each of the models with the pictures that guides you how this component can be adjusted. And when you place the component in the right position, you can produce the holes automatically. So there will be no situation when you have misaligned holes or something, because if you place the hardware in the right position, then you can be sure about the drillings. And this hardware library, which is shipped with Woodwork installation, is unified by many manufacturers. What does it mean? When we have some hardware components in our library, we mostly we mostly care about the right drilling position. So you can see different hardware items on the left side. They have something in common, despite the fact that they are made by different manufacturers. They are made of different materials and so on, but they need to have the same drilling on the facade of your model to make sure that you can mount them. So that's why you can replace all those hardware items with a single unit of a Woodwork for Inventor, which can also be different in size, different in center distance. And many components of the same family can be replaced with a single Woodwork component, and then in a BOM you can define the code and the name of a manufacturer catalog. It makes production easier. So you don't need to care about big amount of the items in the library, because in most cases they are standardized. If you would be a hardware manufacturer, and if you make like some triangular holes for your handles required, then nobody will purchase your hardware, because it will need to change your workflows on the factory. Okay, so now we can see how it actually happens. So first of all, we can define some parameters which will control the position of the hardware planes. So we define some parameters, and what we can use them for to set the work planes. They will be used as a guide geometry. So we can set some offset from the front, like so, use the parameters, and do the same from the back side. So in this case, if you change the depth of your unit, this relation will remain. So we have some distance from the front edge and from the back edge. So now I will isolate some of the component and show you how the hardware positioning works using them as a reference. So what we can do, we can use a Woodwork functionality, join attach, choose the library component, and we added some new components on each of the releases, so this is not exception. So those of you who are familiar with the 10th version will find some new hardware items in the 11th version installation. And to place the component, it's enough to just click on the reference geometry. Yeah? So it's asking about the bottom of the shelf, it asks about the edge and the plane. So if you indicate all those requested geometrical items, then the hardware component will be placed in the right position. Okay, so we did this for a single unit, and of course we can later multiply the amount of them, because the shelf was made by a pattern. Yeah, so we can just say that we want to include the hardware components in the same pattern that controls the amount of the shells. And that's basically it. So you can see we just have them all on the right place. Okay, perfect. So what is the next step? We can hide panels or make them invisible. And actually you can see through the model, you can see the structure. And then you can find the component that need to be adjusted. For instance, the dowel of this minifix must be on the opposite side. So I can find the component I want to tweak, change the side of minifix, of the dowel, and then this component can be used as a reference to change the others. So I'm using this as a reference. Then I'm clicking on the component that need to have the same configuration as the previous one. Okay. So as you can see, it doesn't take a lot. And this allows you to make very flexible designs. So we don't use some logic. Of course, you can use some logic of your components, but in most cases, you still need to visually check if the component fit. So there you have like very flexible tools to actually adjust the hardware position, configuration to meet your design. And once it's done, we can just make the drillings in the next step. We will see how it happens later when we will place some eyeboxes. Okay, but before doing this, let's speak a bit about the wooden joints. Some of your design may contain these wooden joints. So in a similar manner as we saw in the previous step, you can make any custom wood joints. So what is the difference? Wood joints can be made only by, to make wooden joints, in some cases, it's enough to only change the geometry. Yeah? You can have like mortise and tenon joints and that kind of stuff. So you don't need to have additional components. But on the other side, you can also have like a mixture, like a combination between a wooden joint and some hardware. Like for instance, you have mortise and tenon joint, which includes the dowel to make it more robust to some forces. So of course, those components can be made in the same way as the regular hardware. You can control their sizes using Excel file. You can have some iLogic rules embedded. Like for instance, if the length or the depth of the part is in that range, you can do some configuration changes. Or you can make like a left or right configuration and so on. Some of the component should be disabled, some of those should be enabled. That's the same for relations inside of the file. But this is not the training, this is like just a regular demo, so that's why let me just go for the next step, which will be an iBox. So what does iBox mean? In the very beginning, I showed you the workflow, and I said that we can just simplify the work by utilizing some predefined components, which can be the drawers, cabinets, cases, whatever. So you can basically make like a component and assign the materials, place the hardware, configure the hardware, and set some additional logic to that component to make it possible to use in the future designs. Like say, what parameters control the width, what parameter control the depth, height, and so on. And later you can just make a copy of this component, place it in your design, and adjust its size. So that's how it works. Let's see how it happens in our case. Okay, so that's the place where we want to utilize the iBox. So we isolated this gray box we made in the previous step. And then we're using iBox insert, choosing the iBox item, and then configuring the naming scheme. And once the component is placed, it's enough to just select the top, the front, and the side. As you can see, the component changes its size and is placed on the right position automatically. This also includes some hardware items, some materials. The grain direction and oversizes can be set as well. So as a next example, as the iBox can be used in this model, can be the doors. So for the doors, we can choose the same workflow. They can be designed in advance and used in many designs. To place the door, I need to choose the front, the side, and the top, and that's the door on the place. And so those doors can be different, like the left side, the right side door, and so on. But basically, the idea is the same. So what we're doing, we're just saying where the front, the top, and the side will be. Okay, so if you will have like some objects that can be used in the future, you can quickly make them eyeboxes. So each regular component you made, each cabinet, each door, each drawer can be converted to be eyebox quite easy. Yeah, so if they are designed using skeleton design workflow, we recommend to use only this way. Woodwork have no restrictions, but we find that this is the best way. So each object made using this workflow can be easily converted to be eyebox in a matter of minutes. And then you can use it in your other designs. Now, this model is completely defined, and we can move to the next step. So since the model contains all the information, it contains the materials, it contains the hardware components, we define the grain direction, oversizes, and so on. So now we can go for the next step, which will be a bill of material generation. And those of you who doesn't use some automation tools know how long does it take to make a BOM, to make a bill of materials. So this is a very routine process, prone to errors and so on. So let's take a look what do we made here. In the bill of materials, first of all, we have model-based bill of material, which makes it's highly efficient. So what you have in the model actually will be converted into the BOM. You can see cut panels, edge bandings, and all the materials you set. As well, we can have dimension quantities of the materials, purchase units, order information, and other stuff. And that's one of the examples how the BOM can look like. Why I said one of the examples? Because you can easily control how the bill of material looks like by changing something we call a template. So there's like a specially formed Excel file which controls the parameters, and it actually shapes the bill of material you're generating. Later we will see how it happens. But before doing this, let me explain one more thing which is related with the materials. Let me just go back a few steps and speak about the material groups. So what you can do in the very beginning, when you start to work with the models, you can say that your model contains 2 or more different materials, like facades and the body components. And for instance, in this case, we have only 2 kind of materials, so facades and the body. And later, what you can do, you can actually say what the real material used for the body components and facade components on the BOM stage. So on the design, we had body and facade materials. That's it. On the BOM stage, what we can have multiple mapping schemes. Like in this case, let's name them like dark, light, and modern styles. And each of those styles can have different colors, different textures. So we can do material mapping, which makes it possible to have a single model which will be changed in a matter of minutes to have a different material schemes. Similar story can be applied on the hardware. You can have a single hardware item and then assign real names and real codes to be shown in a BOM. Okay, so let me explain why we did this in that way. Because at first glance it can look a little bit overcomplicated, not obvious why we do so. So let me explain. So say that we have some body and the facade materials in the model, and then we use material replacement stage to assign real codes, names, and textures for the components. How we can get them from? We can use ERP system, which most of you probably are using right now, to generate some snapshot of a current situation on the factory. So we can basically generate a list of components, a list of materials we can operate with. And then, since this moment, when we did a replacement, on the BOM we will see those real codes, real names, native for the ERP system. And then we can send them back to the ERP with the quantities. Yeah, because what we have in the model, we have the size of the panel. What we have on the ERP, we have our names and codes. So we blend them together to get like a precise BOM with real codes and real names. And those can be used not only in the BOM, but in the drawings and the CNC programs as well. And all this final data can be sent to the PDM. Of course, in this case, we're speaking about the vault. Maybe most of you, I believe most of you knew about that PDM system. So if not, if you need to have more advice about the vault, I think you should contact your local resellers to have a discussion about that. I will touch the vault topic a little bit more in details in the future. But now let's see how this material mapping happens. So what we do, we just request to make a new material scheme. We give it a name, and then I can expand the materials, and that's one more new feature of the 11th version. This dialog looks way easier, way more simple than it was before. So what we're doing now, we're defining the source document, the Excel file which contains the image path, the code, and the name. And as you understand, this Excel file can be generated by the ERP system, and you can use it as a source of the data. So there you can see materials, and you can find the right material you want to use by just typing its name, okay, or code, or just scrolling in the list, and that's it. So we basically can define the materials for the different components in the same way. So the components here are grouped by the material, and inside of one group you see division by the thickness. Okay, so we did a material replacement. Okay, and since then those codes and names can be used in our next steps. Okay, so which will be the BUM export using templates. So let's go back to the BUM, and here you can see that I can choose a template to export my final BUM. Of course, this new installation contains new templates, so if you want to see them, because we don't override existing templates, just move them existing templates in some other folder, and you will have new templates after the installation. How they work? They work by using some keywords, like just some parameters that you can place in the right location. Using keyword constructor, with the explanation, with the detailed explanation, you can see what this keyword will actually indicate. Like maybe you want to know item code or item name, or maybe I want to know fill workpiece length or thickness. So I'm looking for the right keyword, and I'm placing this keyword on the right position in my template. And since then, this Excel file can be used for an export. Okay, I give it a name. I give a name to the output file. Very clever name, I know. And then we can just give a command to generate the file. So this is one of the examples how the final wrapper can look like. Of course, each company have their own vision about how the best BUM in the world should look like. So you can easily adjust your templates to match your needs. So here we can we see different spreadsheets, like product structure, part list, cutting part list, and so on. And all they can be adjusted to the user. So we have something on the purchasing side, yeah, so maybe it's not interested to know about cutting and so on. Maybe they only need to have material summary. Yeah, so we can have multiple sheets of the document with different data dedicated for exact person or exact user of this data. Of course, the template can be changed. You can use not only the keywords, you can use formulas on top of that. You can even use the scripts of Excel to make it work as you expected. For instance, if you see the length of the part is bigger than some reasonable value, you can use some script which will show you a warning message that this part is too big, for instance. Or you can take material summary like we see here, and we have like rough amount of material. Then you can multiply it by a prime cost to estimate how much it will cost more or less, even before generating and nesting, because the price, the total price, of course, will include the nesting. Okay, what do we have here? It's like a separate what's new document included in a installation. So those of you who are familiar with the previous one can just look at what we have here. So for instance, there we have the position numbers. Some of you asked about the raw board size calculation along the grain direction. Some of you asked about to have separate file, separate page for exact part. We also included QRs in the thumbnails, so you can see that for this separate part we can use a QR code or barcode depending on what you want. So in 11th version we have them available for your service, so you can have a like separate specification for each unit on the separate sheet of the Excel file. The other reason why you may want to use them is for exporting to the ERP systems. Some of the ERP systems requires to have like a separate spreadsheet of Excel with the data structure. So we can do so using Excel. Of course, it's not possible to explain all the nuances of the new functionality of the BOM export in this session, because there's direct comparison needed. But it's not the case, as I mentioned in the very beginning. So if you're interested, just write us and maybe we will do a separate explanation for you if you want to just get familiar with only new features. Okay, so now let's see what we have on the drawing side, because one drawing can replace 1,000 words, as you know. Of course, those are generated automatically. They're driven by the templates. You can see multiple items in the drawing. Like for instance, you can have a whole table with whole IDs, with the grain direction, with the custom symbols. You can have custom parameter in the title block. You can have a dimensions and so on and so forth. So, for instance, what we can customize, what we can adjust. You can see that this drawing contains some custom tables. Those of you who are familiar with the 10th version will notice the difference. So we have a custom table, like for instance edge banding or composition of the part, and that's one of the new features of the 11th version. So you can make like a custom Excel file and then place it in a drawing, yeah, and this Excel file will actually pull back the information from the model and place it in a right location for your needs. So what we can adjust, you probably read most of the text on the right side. We can change the title block, we can include Woodwork parameters in the title block, we can define a title, we can define a whole table, how the drillings will be shown. Of course, we can include custom BUMs. Basically, we can utilize any Woodwork data we operate. Yeah, so if you need to have like the size of the workpiece, the size of the part, the thickness of the material, and so on and so forth, all that information can be included into the drawings. So you can have different order, different layouts, use custom symbols, custom IDs for the drillings, for instance, custom projections, different line styles, colors, and much more. And normally in the training, this topic about the drawings takes about 2, maybe more hours. So as you understand, it's nearly impossible to explain that. But I believe you already got the idea of what we can adjust. Moreover, if you use some CNC programs before drawing generation, we can get a base point on the drawings as well. So if your workshop guys need to have the drawings as a reference, that's not a big deal. With Woodwork, we can automatically place the base point on the drawings without additional efforts. The drawing position will be the same on the BUM, in Excel, and on the drawing. And if you use like a big large assemblies, there might be a question about to whom this part belongs to what sub-assembly does it goes. Yes, so Woodwork allows you to show a parent assembly in a title block as well. So you know that this part is included in that sub-assembly of that main assembly. So that's quite a significant benefit. Now let's take a look at the drawing generation. When we place all the Eyeboxes, all the stuff, adjust all the hardware, we need to make the sculpt operation. And that's one of the new features. Those sculpt operations now are associative. So if you change the position of the work plane, you don't need to make the drilling again. It will be right in the correct position. So you can see those associative side on the left. What we did in the background, I choose the template of the drawing, and then I pressed autoplot button, and as you can see, that's the result. So basically we have all the panels aligned in the right way. Holes are oriented on the top. we can see all the dimensions needed for the drillings. We have all the IDs, and we have the custom tables. Of course, the look of the drawing can be completely different depending on what is your intent, what you would like to achieve. You can remove the texture, change the line styles, make it bigger or smaller. Maybe you want to include some projections, so it's doable. That's not a problem at all. On top of that, we can include all the adjustments Inventor allows you to do. And because Autodesk company is one of the leaders of the market, you can imagine that all the necessary adjustments that you can imagine can be found in Inventor. So in some of the cases, our customer uses the drawings for making a CNC. But on the other side, some of the customers does not use the drawings for CNC production because Woodwork allows you to make CNC and the nesting based on the model. So in some cases, you can just skip the drawing generation for the parts. Now let's speak about the nesting and CNC. So first of all, what we should do, we need to define the job. Yes, and how we can do this. We need to include all the tools we have. And of course, in each new release, we add some new configurations of the hardware, but it's highly flexible, so we can include the tool configuration you may use in your machine, and then define the machine properties. What spindles do you have, how the tool can be rotated, and so on and so forth. And all that makes the machine configuration. So you can see some of the machines we include in the installation. Yeah, so when you define all those rules, this can be set as a machine. On top of that, we can apply some rules which defines how this machine behaves. Yeah, so we can just name it like some sort of basic artificial intelligence. Yeah, so we can say what to do in that or the other circumstances. Yes, define a tool, define the order of the operation, what will be the best point, and so on. What is the weights when the system takes the decision? All that can be adjusted. Okay, and what is more important, that CNC programs are generated based on geometry. So we don't care how you made the shape. For instance, for making a hole, you can use the hardware, or you can just make a cylindrical extrusion, or you can use the hole tool of Inventor, and all that gives you visually the same result. So what Woodwork does, it analyzes the geometry and makes a decision about how this geometry can be processed, and run this post-processor step to actually generate the file that you can place on your machine and run it. So what we do, we can generate a final output file. And here you can see some of those files that we can generate. Okay, so of course you may not find the extension you're using. So what we can suggest you in this case, just contact us or our partners, and we can make a custom post-processors on demand, but this is like a separate topic. So we include most common formats used worldwide, but of course you may use some other machine, and then we need to have additional discussion about how to solve your exact question. Now let me show you how this happens. So first of all, we can click on the status sign, and you can see that those red indicator shows that there is no CNC programs. So now we can choose the nesting machine to produce nesting contours of the parts. Okay, and then I can actually generate the nesting layout. As you can see, we have all those nesting properties. Each part contains the number, it contains the ID, yeah, so we know what is what. And then, of course, we can change the alignment, change the position, and produce the file for the nesting. Now, when the nesting files were done, as you can see, it takes just this is the matter of minutes. We can actually produce a CNC file. So we cut it out, the part from the nesting layout, and then we can just make a CNC program. Again, this happens automatically in the background using some logic based on the geometry. So there is no need to assign the tool, set the geometry, and so on. It will be done automatically. Yes, so you can see that all the operations are presented. So we have milling here, drilling, and so on. So if you like, you can change the parameters manually, not a problem at all. But of course, in most cases, you will use some automation. You will set some rules that system will be guided by, and it will produce the results you don't need to adjust in most of the cases. Yeah, of course, maybe you're using some complicated geometry, and then you can manually tweak and tune the results. So this part have a nesting contour as well as all the operation for CNC. And if you want, you can run a simulation. Yeah, so you can run a simulation. There are some improvements of the simulation as well. Yeah, so now it can simulate the operation more precisely. So that's basically it. We see that the part is right in shape. We run the simulation, it's okay. So we can actually finish the CAM environment, go back to the assembly and run the program output. Okay, so we can just say, okay, we checked the files are correct. And when we do this output step, it actually produces the files. So what it did, it produced 80 files, which is MPR in this case. So they are native format for a Woodwork software, which is used on the home machines. So we can run the Woodwork, and then we will see what is the result. What you can see on the file actually depends on the extension. Some of the files can allows you to have some additional information, some of those not. But in this case, on the Woodwork, you can see the grain directions, you can see edge bending, you can see a clamping point and the condition, what you're placing on the part. Is it a part or is it a workpiece with covers or without covers? So your CNC operator can see it on the screen, so there is no room for mistakes, because if you read the drawings you can always make a mistake. Yeah, but if you look at the screen of your machine, so there's no chance to do something wrong. Now let's speak about the parameters, because everything we did was based on the parameters, so those leads to easy changes. So how we can do some modifications? First, maybe I want to keep my original model, so I can use an assembly copper tool, which allows you to make copies of existing designs, or maybe you want to change the names, apply codes instead. So you can apply prefix, suffix, or you can use a replacement tool to change the names of the files. So in this case, I will add just the suffix copy on the end of the current file name and the part number. And then I can start my copying procedure. So I can have a new copy of my design with the new names, and they are independent. Yeah, so if I want, of course, I can reuse some of the files, but now I made independent copy. And let's say I need to have a new design. Yeah, so maybe I want to have like a non-symmetric unit. Okay, so maybe I want to have like changes on the partition. Okay, so what I did, I just switched the work plane's position. And when I update the changes, you can see that actually Woodwork recalculates what we have. The iBoxes, Inventor recalculates the position of the components on its site. So basically we just refresh the models, components. Of course, we can change the quantities of the shells and whatever else we want. And then we can set a new material scheme. Yeah, you remember that step we made in the previous stage. So let's imagine a situation that our customer saw the wardrobe, but he wants to change the size, the proportion of the doors, amount of the shells, and the colors as well. So what we did, we just made a copy, and then we set a new color scheme in this new refresh dialog. And then when we set this applies this image replacement scheme, the model changes, and that's how it looks like now. So that's the new scheme, and now we can run the bill of material generation, we can run the CNC files, and we can generate the drawings. So as you can see, in a matter of minutes, we made a new copy, and that's basically it. So of course, we can change this to be iBox, and then make a room layout, and then place that furniture models in our room layouts, where on the places where this furniture should stand, we will have just reference boxes. Now a few words about how we work with Autodesk Vault. As I mentioned, it's like very wide topic, and if you have questions about Vault, the best solution would be to contact your local resellers. So What is the vault? In simple words, it's like a collaborative environment which allows you to make your designs together with your colleagues, share the data, protect it from accidental changes, make a versioning, and so on and so forth. We have a support of AnyCAD, which allows you to import and export geometry in different file formats. You can quickly look for the data, reuse the data you found. We can have collaboration teams which works on the same design at the same time. Some of the tasks may be automated. You can have a revision, you can manage the BM, you can automate ACO, and in some cases, Vault can simplify your ERP integration. It actually depends how your data flow are organized, but if you have a collaborative environment, then that will be a good point to think about ERP integration, because all the CAD data can be stored in one place, and then you can use it like a point to connect it with the ERP system you're using. So what Woodwork can do in this point? Because I don't want to start my explanation here about the Vault, because it will take many hours. So in simple words, for those who are familiar with Vault, I can say that we can export all the items like edge banding, cover materials, and so on, like a separate working items for the Vault. So each thing you do in Woodwork, each configuration of single panel can be treated like multiple units, which can be read by the Vault BM. So you can use commit items, and all those items will be generated and sent to the Vault. Now let's speak about the time, which is understandable for every one of you. Not everyone uses Vault, but everyone counts how much time does it take to do some production. So those numbers can be different, can vary depending on the industry you are in, depending on the complexity, your skills, and so on. So, but more or less, those are common for most of our customers. If we ask them about how much time they spend on the design and on the production information generation, they talk about such numbers. That on the design they spend 30, on the MFG data preparation they spend 70% of their time, which is a huge amount of time. So they spend on design, let's say 3 hours, and they spend 7 hours to make the drawings, CNC, and of course the most routine task will be the BM generation. Nobody likes it. So what changes when the Woodwork comes in that play? In most cases we can expect double efficiency, but what is more important, that the proportions between the design and manufacturing changes. So you can spend more on the design and less on the manufacturing because of the higher automation. And because of the same reason, because of the higher automation, this process is less prone to mistakes. If you automate it, then it means that there's no room to make human mistakes. So now let me show you a few examples, because I just show you a single boxy looking furniture, and you may think, oh, I don't use that box, or you design something more advanced. So that's not a problem at all. You can do any custom furniture you can imagine. Like in this case, you can see that we have like a shopping mall equipment. We can have a mixture between the glass, metal, panels, solid wood components, and so on. You can work with some blocks, like this big assembly can be made like multiple blocks divided into separate subcomponents. Each of those can be detailed. Of course, you can use some metal frames. You can design some metal frames, some custom hardware, different color schemes. On the other side, you can use some retro. You can design some retro furniture, like you can see here, or maybe you can even think about some very unusual shapes. Like in this case, that's the shape of the yacht, and you can see that the shape of the furniture inside of this yacht can actually repeat the shape of the yacht, of the boat itself. And this translucent body, in this case, can be used like a skeleton. What we treated like a skeleton in our case was just a box, but in this case, as a skeleton, we can use the box, the shape of the yacht cabin, right? On the other hand, we can also work with some triangulated sharp surfaces. Like in this case, we have some modern furniture, so we can do this without any problems at all. And of course, if you have some fancy geometry, structure, and so on, to hold that structure, you may use some metal. Yes, especially in case if you are working on the shop fitting environment. Yeah, so if you just do some custom furniture for the shops, you know that you should use some metal structures. So you can combine the things made of the metal with the cover made of wood, or support made of wood, or vice versa. So you can blend them, and blend the materials, blend the shapes, and do something of the metal as well without big problems. On the other hand, if you have a need to have like a wave-shaped furniture with smooth transitions, this can be also done. Like this example contains the frame inside, which is covered by pieces of veneer, and this looks very nice. It looks like a single piece, but of course it has some rigid structure, rigid frame inside. So this can be also done as well. Of course, when you looked at all this demo, maybe some of you already have a wish to try the software. And that's not a problem at all. If you want to try how the Woodwork for Inventor works, you're welcome on our web page. So here you can download the trial version, which will work for a 45 days period. There's almost no limitation on the functionality. Only one is related with the material editor. So you can use the Woodwork like a trial to check if it meets your need. And of course, if you need any additional information, please contact us or our resellers. And this, I'd like to thank you very much for joining us in this event. I was really pleased to see such a lot of people joining us. Appreciate your time. And if you have any questions, comments, or ideas, please share your thoughts using this email. And this, I'd like to thank you once again, and I wish you a great day. See you. Bye-bye.